My YouTube channel Sriram. Today I am going to discuss another problem from CSIR Net Mathematical Science question paper from the year December 2025. The problem is from part C. The problem is from complex analysis. The problem number is 82nd one. For t belongs to close 0, 2 pi, let gamma 1 of t is equivalent to e power it and another gamma 2 which is equivalent to 1 plus I plus e power it. Which of the following statements are true over gamma 1 and gamma 2? For the first option, over gamma 1, integral dz by z sin z is 0. Over gamma 1, integral dz by z sin z is 2 pi I, which is second option. Third one, over gamma 2, dz by z sin z, integral value is 2 pi I. Last one, integral value must be 0. Since the problem is from part C, more than one option is the correct option. First of all, solution. What is gamma 1 of t? E power it. That is modulus of z less than 1. Here radius is 1, center is 0. What is gamma 2 of t, which is equivalent to e power it plus 1 plus I. Here center is, we can write this one as modulus of z minus 1 plus I, which is less than 1. Center is 1 plus I, radius is 1 for gamma 2. Here center is 0, radius is 1 for gamma 1. For gamma 2, center is 1 plus I, radius is 1. For the first two option, gamma of 1, dz by z sin z, which is equivalent to integral over gamma of 1 f of z dz. Here what is f of z? Z sin z. We can write z sin z from the expansion of sine series. We can write z minus z cube by 3 factorial plus z power 5 by 5 factorial dot dot dot. Take z outside, z square 1 minus z square by 3 factorial plus z power 4 by 5 factorial dot dot dot. Here problem is 1 by z sin z, that is nothing but 1 by z square 1 minus z square by 3 factorial z power 4 by 5 factorial dot dot dot. 1 by z square 1 minus z square by 3 factorial plus z power 4 by 5 factorial power -1. Here z equal to 0 is the only one pole lie inside gamma of 1. By using Cauchy residue theorem, we can write it as 2 pi I into sum of the residue that lie inside gamma of 1. This is gamma of 1 dz by z sin z. That is to find residue of f of z at z equal to 0 for the above. Here there is no coefficient of 1 by z in the above series. This is the method to find residue. The method is to find the coefficient of 1 by z in the Lorentz series expansion for finding residue. But for this problem there is no coefficient of 1 by z. Here there is no coefficient of 1 by z. Therefore residue of f at z equal to 0 is 0. Therefore 2 pi into 0 which is equivalent to 0. From the first two options, the first option is the correct option, second one is a wrong one. For the third one and the fourth one, we have to check for gamma 2 of t, that is 1 plus I plus e power it. Here gamma of 2 of t is 1 plus I e power it, z equal to 0. Now I am going to check whether this z equal to 0 lies inside gamma of 2. That is z minus of 1 plus I must be less than 1. Modulus of 0 minus 1 minus I must be less than 1. This is nothing but minus 1 minus I less than 1. This is nothing but 1 plus 1. It must be not less than 1. Since z equal to 0 lies outside gamma 2 of t, therefore residue which is equivalent to, that is residues of f at z equal to 0 is 0. Therefore gamma 2 dz by z sin z by using Cauchy residue theorem, sum of the residue which is equal to 2 pi I into 0 which is equivalent to 0. For the second curve gamma 2, the value of the integral is 0. Third one is wrong option. Fourth one is the correct option. For this problem, option 1 and option 4 is the correct one. I will upload more problems from CSIR.net Mathematics Science question paper. Subscribe my channel, like my channel, share my channel to your friend. Thank you.